Example 7, use the alternative derivative form of the derivative to find the derivative of f of x equals x to the 1/3 power at x equals 0. So we have the function here. We want to figure out the derivative, the slope at this point here. Okay, remember the derivative is a fancy way to find the slope of the tangent line at that particular point. So the alternative form for the derivative would be f prime of c. Remember, c is another way of saying at a specific x value. So f prime of c equals the limit of f of x minus f of c all over x minus c as x approaches c. Okay? And remember, in order to use this, we need to use limits coming from the right and coming from the left. So first of all, for this problem, does it make sense that c is equal to 0? F of c would be equal to c to the 1/3 power. Okay. F of x is just x to the 1/3 power, and x is obviously just x. So f prime of c, which is 0, we're trying to find the slope of this function when basically we're looking at the c value is 0, it's just an x value, is equal to the limit of f of x. F of x is x to the 1/3 power minus f of c. So f of c here is really going to be f of 0, which equals 0 to the 1/3 power, which would be equal to 0, all over x minus 0 as x approaches 0. So then we can simplify this. F prime of 0 equals the limit of x to the 1/3 power over x as x approaches 0. And first of all, I'm going to do this. Well, I actually need to simplify this more. Then I have f prime of 0 equals the limit. Here, when dividing like basis, subtract the exponents. So this would be x, or you could think of this as being x to the negative 2/3 power, which is the same thing as f prime of 0 equals the limit of 1 over x to the 2/3 power as x goes to 0. Okay? Now we have to do limits coming from the left and coming from the right. So first of all, let's do this limit coming from the right. Coming from the right would be this way. So this would be a very, very small positive number. So if you think of 0.00001, okay, if you would plug this into this function, you're going to be taking 1, and this is really the cube root of 0.000001, and then you're squaring that. Okay, so that's going to be a very, very small number. So this is actually going towards 0. Remember, 1 divided by 0 is the same thing when you have a limit here. This is the same thing as infinity. Okay? As long as this denominator is positive, which it is here. So this is going to be equal to positive infinity. Let's look at f prime of 0 equals the limit 1 over x to the 2/3 power, or you can write it this way, the cube root of the cube root of x, and then square that. That's the same thing as this. As x goes to approaches 0 coming from the left. So now it's going to be a really, really, really small negative number. But if we plug that in to the cube root, we can have a negative number underneath the cube root. That's going to make it even smaller, but then you're going to square it. It's still going to be a really, really small number. When you do 1 divided by a really, really, really small number, that's eventually going towards 0. So this is also going to be infinity. Okay, so you can't really have a slope of infinity. Well, all that is telling us here is, you would say that the derivative at 0 does not exist. That's technically the answer. Okay, because that's this line here. That's slope undefined.